All right, let's get started. So last week we had testing strategies, and we didn't have any tasks associated with it. It's more tips and tricks, kind of a little bit of a catch-up week. We're back to content that has a task related to it, but I actually don't have too much to explain in lecture about the task. It's one of them tasks that I'll cover everything in not too many slides today, and then actually coding it in your homework will be a little trickier. But I don't think it's too bad, to be honest. But let's take a look at what Task 6 even is. So Task 6 is going to be about writing methods that read files, which in my opinion isn't too bad. You're going to write a method to read song data and a method to read movie data, the two kind of pieces of data that we've been working with. And like I said, I don't think that's too bad. The more challenging side of this assignment, and one of the underlying themes of 116, is testing these methods. How do you test a method that takes a file as a parameter? Because otherwise it'd be a 115 assignment. You've done file I/O already. But let's take a look at the data that we're going to use. The movies.csv, it'll just want to download it, so I can't exactly show it, at least not easily. But it's going to be CSV data with the movie title, and then any number of cast members after that. And then for the song data, we have this absolutely stunningly beautiful app, if it ever loads. I don't know why this is loading so slow. Hopefully it's a Wi-Fi issue, not a website issue. Where you can add songs by Spotify ID, title, and artist, and then rate songs that other people have submitted to the site. And then we'll use this data. We can do the ratings.csv here to see all of the data that's been uploaded to the site. And then we can use this data for testing, or use this data just to find out what the best songs are according to CSE 116. And I do use, bless you, and I use this information to get new songs added to the playlist that plays between lectures. So if there's songs you want to suggest, I do use this once we have a lot of data in here. Bless you. Once the assignment's rolling and people are using the site and getting ratings in there, I'll use this, make a playlist of like the top 50 songs that are rated, and then start adding things to that playlist. So we do actually use this for something, for what it's worth. And your task, the song data, I didn't go over the format. ID, artist, title, reviewer ID, and then rating. Each one of you will have a reviewer ID in the system. And that'll be the lines of the CSV file that we just had open. So these are the two formats that we want to read for the homework assignment. And the methods are pretty straightforward given all that background. There's a read songs method that takes a file name and reads those songs, expects them to be songs in that format, and a read movies method that takes a file, a CSV file in the format that we're expecting for the movies, and reads that. And each one of these returns an array list of all the songs or all the movies that were read in the CSV file. And like I said, I don't think reading the files is overly complicated. Reading the songs is a little tricky because a song can have multiple ratings. So when a song appears multiple times in the file, that part gets tricky. So I shouldn't say it's objectively easy. That part's a little tricky. The movies are only going to show up one time, so that's not as bad. But then testing. How do we test methods that take a file as a parameter? And for that, we're going to create test files. This is what we'll do on Wednesday. We're not going to get to this part today. Today's just about how to read files. We're going to create files, our testing files with testing data, call the method with that file name, and then make sure we get what we expect. We know what to expect because we know what we put in the testing file, and then make sure that that's what we get in return. So that's how we'll write our tests, which takes a little work to set up. You'll put all of your testing files in a directory named data. That's a lowercase d, lowercase d data. We should all be used to, by now, I hope, that capitalization does matter in programming. It matters a lot. Lowercase d-a-d-t-a data. I say that because I had a few students in office hours last semester wasted hours of their lives because this was a capital D. And they didn't know why everything was breaking in Autolab every time they submitted. This has to be data. Autolab's going to look for a directory with this name and treat that as your test file directory, so it'll make sure it preserves that directory. It's spelled exactly like this. So this directory and your test directory are going to be preserved during testing. And then actually implement the methods. Bless you. Okay, so that's what we're asked to do. Oh, I didn't. Let me scroll back up to the top here. So that's what we're asked to do for task 6. Any questions on any of this before we get into content about how to do that? And in chat was just an answer, not a question, so let's do it. Reading files. So first, why even bother with files? Is a question we should have. Of course, you talked about this in 115 if you took 115 here. So if you didn't take 115 here, wherever you're coming from, didn't do any file I.O., let's talk about it. Or if you just need a refresher, reminder of why we did file I.O. to begin with, why do files even exist? Should be questions you should have at least asked yourself at some point in life. Maybe not in life, but in your computer science journey, at the very least, is why do we use files? So the problem is everything in your program is stored in memory. Everything that we've done is in your memory diagram, stack or heap. There's no third option there. Everything in our programs was stored in one of those two things. Both of those are in memory on our RAM sticks in our machine, and that's all temporary storage. Every data structure you ever create dies with your program. Once your program ends, those data structures are gone forever. They do not exist after the life of your program. So if we want data that persists beyond the life of your program or before the life of your program, we're going to have to go to the hard drive. Well, I guess I shouldn't say have to, but we're going to go to the hard drive. You could go over a network and store it on somebody else's hard drive. But we're going to go to the hard drive to have persistent storage. That's what we want. So now on the hard drive, our data is going to live beyond the life of our program. So if we want to store data and save data after our program ends, we're going to save it to disk, which we're actually not going to do in 116. I don't know why. Maybe in a future semester I'll do writing files too, and do true file I.O. instead of just file I. But we are going to read from disk. So we have data that's already stored on disk, and our programs are going to read that data that existed before our program even started and then process that data. So that's why we saved to disk. Then eventually in your career, you'll go on to databases. Databases add a layer of abstraction here. So the database will be your go-between between your program and the disk. And then the database will store your data to disk. If I'm sure you've heard the word database before, but you might not have messed with them quite yet. Actually, you might have taken 115 when we still did a little bit of databases. But this semester they don't do databases anymore or web stuff. But the database is your go-between. It's going to save to disk. It's saving files, but it's abstracting how it's stored in how your data is stored in files. And it's going to add a lot of efficiency and a lot of organization to that. Instead of maintaining your own directory structure with the files, say you have a program that needs to save 1 million files to disk. Instead of you worrying about how to organize all that data, the database decides how to organize it and make it very efficient to read that data from disk and to save more data from disk. So that's the reason we use databases. It's because file I.O. gets tedious if that's the only way we're storing data. So the database helps us do it better without having to think about it too much. So let's read files in Java. This isn't going to be too much of a stretch from reading files in Python, again, in my opinion. It's not too much of a stretch. If you understand reading files in Python, this is just learning Java syntax. Just I shouldn't even say but a Java way of doing it, a Java way of reading files. And this is it. Here we go. This is our example. This is how we'll read files in Java. So with this code, what we want to do is take a file name and then return an array list of strings where the array list contains all of the lines in the file. Each line is a string in the array list. So if this file has 5 lines of text, this array list that's returned is going to have 5 strings, where each string is a single line in the file. So let's break this down. So Java can't just take a string as a file name and read it. We have a little bit of extra work to do just because Java wants to be Java and make us do an extra step, whereas Python just lets us open a string and it'll say, I think you mean a file name. Like I'm going to treat this as a path on your file system. Java's not going to do that for us, so we have to convert our string into a path on our file system. And for that, we're going to have to import the library paths. Paths is a class with a static method named get, where get does exactly what we want, converts a string to a path. So that's just a step that we have to do. We're working with Java. We're going to have to convert our string to a path as a separate method call. Then we're going to import files. Files has a static method read all lines, which takes a path, not a string, which we have a path. So we're going to give it our path. And then that's going to return all of the lines of the file. It's literally going to go to this place on our hard drive and read all of the lines of that file and then return all those lines as a list, which I'll talk about list in the next slide. Actually, I'll avoid talking about list in the next slide. But first, one of my disclaimers. We actually have a decent number of disclaimers this semester. One day, I don't know, if I decide to add complexity to 116, maybe I'll get rid of these disclaimers and just have you do all of this stuff, doing buffered inputs and a few other things we'll talk about later in the semester, strings on the heap. But definitely not this semester. I like keeping things focused because I want to focus on mostly testing methods that take file names as parameters. That's what I want to focus on this week. So I try to get rid of the extra stuff, the auxiliary stuff, but I will talk about buffered versus unbuffered on the slide. I like parking on the slide and talking about it a bit. Yeah.
So because like path stuff, because like the .get method is paired up with paths, is paths like a dictionary?
Paths is a class with a static method named get. Same with files. Files is a class with a static method named read all lines. So since these methods are static, I'm calling them through the class itself. So buffered versus unbuffered. This is an unbuffered file read. Read all lines literally does what it says. It goes to this file and reads all of the lines and returns a data structure containing every single line of that file. And it assumes the file is a text file for what it's worth. So we're going to read all of the lines and load every single line of that file in memory, which is going to be fine for our purposes. This is how we'll read files in 116. Unless you don't want, I mean, if you want to do buffered file reading for your homework, I'm not going to stop you. It'll work just fine. It won't cause issues in AutoLab or anything if you want to do it the buffered way. But if you don't want to think about it, just do it this way. But I do want to give my disclaimer here and talk about buffered versus unbuffered. This works fine for us, but what happens if your file is large? And by large, I have to keep upping this number, but let's say 50 gigabytes. Well, if you have a file that's 50 gigabytes of text and you try to read it using this method, you're going to run out of RAM. You don't have enough space in memory, assuming you have like a 16 or 32 gigs of memory even. You're not going to have enough memory to load that entire file. So this is going to run out of heap space before this method call ends. So it's not going to work for you because this is unbuffered. What we can do is do this a different way using a buffered reader, which uses an iterator to read one line at a time, or some number of bytes at a time if that's what your application calls for. But we would read this one line at a time in a loop, open our file, but don't read the whole thing. Go to disk, read one line of the file, process that line, and then throw that line away, usually by taking advantage of garbage collection, letting the garbage collector take away that string and get it out of there. Then go to disk again, read the next line, process that line, throw it away, go to disk, read the next line. That's a buffered input, which is going to be much more memory efficient, though it might be more time inefficient for what it's worth. Reading from disk is a slow operation. So if we're going to disk one time and reading the whole file, that can be faster than going to disk 100,000 times to read one line at a time for a very large file. So for what it's worth, there's a trade-off between time and space here. Different types of complexity for our programs. But we'll just do the unbuffered input. For my opinion on this, unbuffered inputs I think are pretty fine these days. Most tutorials, most classes even, are going to tell you, make sure you're buffering your file inputs. Always, always buffer your file inputs. Never do an unbuffered file read. We have gigabytes of RAM these days. It's not that big of a deal anymore. If all the files you're reading are under a megabyte especially, who cares if you're buffering that or not? Unless you're trying to squeeze every last byte of memory efficiency out of your program. Say if you have an embedded system, maybe. But you'd have to have an embedded system with a hard drive, I guess, for that to make sense. But if you're very tight on memory, then you would have to buffer your inputs. But if not, man, we got gigs of memory. Chrome really takes advantage of this. It'll take gigs of memory to load a frickin' web page, even if it's the simplest web page you've ever seen. Just use a megabyte of memory. But anyway, you will hear a lot to never do this, to always buffer your file inputs, but they're small files, who cares? And then especially when buffering can be slower. You're taking a sacrifice in speed to save a little bit of memory. I don't know. Unless you have an application like the 50 gigabyte file, you have to buffer that. Don't get me wrong, you have to buffer in certain situations. But just blindly always buffering all the time, not quite necessary. But you will hear that advice. And those people will probably tell me I'm full of crap, so for what it's worth. But anyway, let's move on. Files.readAllLines returns a list. If you don't want to think about what a list is, we will actually talk about what a list is, at least briefly next week when I remember to mention it. It does use polymorphism. A list is an interface. Array list actually implements the list interface. So an array list is a list. And read-all-lines will give us something that implements list. It might even be an array list. But if we don't want to think about that, we can jam this list into the array list constructor and just work with the array list that we've thought about all semester, that we've used all semester. If you want to work with the list directly, knock yourself out, go for it. Just keep in mind that in the homework document, I do say return an array list. So at some point, your data has to make it into an array list before you're returning it. So the array list constructor does take a list, which we've been using all semester too. Arrays.asList also returns a list. And then we jam that in the array list constructor to get that into an array list. And there's one big problem with this code I'm showing you. It doesn't compile. Java won't run this code. This is broken code. Very bad. We can't do this. I won't even say don't ever do this. You just can't. Java will say, I'm not running this code. I'm not compiling it. There's a big problem here in that it's dangerous code. We're trying to read a file, and that file name is just given by a string. This could be any string, ever. It could be the empty string. I don't know what it is. It's just a string that we got as a parameter to this method. Whoever called this method, they can call it with any argument that they want. We'll get that as a parameter and try to open that file, and that file might not exist. This string might not be a valid path to an actual file on our hard drive. And if that's the situation, what do you expect this code to do? What would you expect? To read all lines of a path from a file that doesn't exist. What do you want it to return? Yeah. It'll give us an error. It'll throw an exception is what it's going to do, which can crash our program. So an alternative to this, and what I do on the homework assignments usually is if it's an invalid input, return some empty data structure. I would say return an empty array list in this case. And in fact, that's what I do on task 6, is if the file doesn't exist, return an empty array list instead of the other array list, which is fine for our application, for how we're going to use these methods in task 7. For Java methods, these Java methods that are internal to Java should not do that. It doesn't make sense for the generic application of absolutely everybody calling these methods, no matter what your application is. So what they do is throw an exception if this file doesn't exist, which is what they should be doing. That is absolutely what they should be doing. If they did the same thing that we do on the homework of returning an empty array list, that loses us some functionality because now we don't know if we read a file and that file was empty, or did we try to open a file that doesn't exist. We would have no way of distinguishing between those two situations. In fact, we don't for our homework, but we don't really care either. But if that were the situation in general where nobody using Java could tell the difference between those two, that's just not what we want. So Java really should throw the exception and let us handle it however we're going to handle that. And we cannot guarantee that that file exists. There's no way to do it. We're just going to have to write code that's going to handle the situation. We're going to have to write code that handles the situation of when this exception is thrown. And I'll elaborate that after the next slide, but I want to back up a little bit and talk about what throws an exception means. What does that even mean? And we've seen this throughout the semester. You've seen lots of exceptions being thrown, or maybe you haven't. Maybe you never wrote bad code. It's possible some of you haven't seen any exceptions. I doubt it, though. But some exceptions, you've at least seen an assertion failed exception, I suppose, would be the one that you absolutely would have seen. But we've seen exceptions: index out of bounds, null pointer exception, a divide by zero exception. I'm like, I know I have a few more examples. Popping off a stack, we didn't see these ones, but popping off an empty stack and dequeuing from an empty queue, if you're using Java's internal stack and queue classes, those will throw exceptions. If an exception is thrown, it's going to crash your program if it's not caught. We can catch exceptions and prevent our program from crashing, which is what we'll do with file I/O. But if these are uncaught, and we haven't caught any exceptions, unless you on your own decided to, if you haven't caught an exception, every exception that's thrown crashes your program. And I have a typo on the slide. I got to fix this. But Stack Overflow is actually an error, not an exception. You cannot catch an error. A Stack Overflow error is going to crash your program no matter what, and there's no recovering from it. You can't do anything about that. The rest of these, the exceptions, we can actually catch that. We can catch a null pointer exception and say, if I get a null pointer exception, then do this, which was technically an option when you're testing linked lists. You can expect an exception to be thrown if something happens that you don't expect, and then catch it, and then assert true of false and fail that test case, fail that program. But we need to catch the exception. We're going to do that using a try-catch block. So we're going to attempt or try to run the risky code. We're going to use the keyword try, create a try block, and put our risky code in the try block. Now, what this will do is run that code as usual, unless an exception is thrown. If while we're in this try block, an exception is thrown, we're going to catch that exception and move down to our catch block, which in this case, we're going to expect an I/O exception to be thrown. This is the exception that's going to be thrown with a message of file not found or couldn't find resource, or I forget the exact wording, but it's going to say file not found in some words. And we're going to catch that exception. This behaves like a parameter list. I have a variable of type IO exception, and I named it E. It's E or EX or or exception, if you want to spell out the whole thing, are common names for your exceptions. And then this code is executed instead. So as soon as an exception is thrown, this code stops, the block terminates, and we go into the catch block and run this code instead. And this code compiles, this runs, and Java will happily compile and execute it. All right, so I said we have to do this. Like, we actually have to do this. We cannot write code that guarantees that an I/O exception won't be thrown or that a file actually does exist, which is a pretty bold statement. In most cases, we can write code that makes sure we don't throw an exception. If we want to avoid a divide by zero exception, I'm going to say if denominator equals 0, don't do the division, do whatever else, return infinity or whatever I'm going to do. If my index I is greater than the size of this data structure, greater than or equal to, I'm going to have an off by 1 error in my imaginary code here, greater than or equal to the size of the data structure of the array list, then don't try to access the value at that index. If it's negative, don't try to access it either. So I avoid my index out of bounds error. Like, we can do these checks to make sure that we don't throw an exception. And there are, in fact, methods. We can say, hey, does this file exist? It's going to return true or false. And I'm only going to open that file if that method returns true. So I'm going to say, if this file exists, open it, else don't try to open it, because I'm going to get an I/O exception, which seems reasonable. But in the other cases, that'll actually work. In this case, it will not always work. It's not guaranteed to work, because we took a big leap when we moved to file I/O from memory to the disk. In the previous examples, the divide by zero, index out of bounds, everything in those examples is in our control because it's all in memory. It's in our stack and our heap. That stack and heap are designated for our program and our program only, and nobody else can touch it. Once we head over to disk, the disk is shared with every process on that device. And there can be lots of processes running on a single device that might all be accessing the disk. So there's a possibility, there's a window of possibility, of opportunity here for us to say, does this file exist? That method goes to disk, checks if that file exists, says, yep, it's right here, return true. And then there's a delay while our program is starting to execute the next line of code, where some other process on the machine might go over to that file, delete it, and then we try to open it. Then we get file not found. Because everybody has access to disk, we can't ever trust what we're going to read. The best we can do is handle the exceptions when they're thrown, because they might be thrown. We have no guarantee, no way to guarantee that that resource exists. And the timing is very small. If we have our code, back to back, does the file exist? Then open it. But it's still a window. There's still a possibility, and we don't like leaving things to chance. If we have an app with millions of users, somebody will have that bug. It will come up eventually. And it might be more common than you would even think, because there can be a process that's monitoring your hard drive, monitoring your file system, and that process might react to us checking if the file exists. When we go to check if the file exists, this process might see that we checked if it exists, and then in its reaction, maybe that software has a bug, or maybe for some reason this is the design functionality of it, I don't know. But it sees that you checked if it exists, it reacts to that, and then moves the file, or deletes the file, or changes the file, and even if it changes the file in some way, that still might mess up our code. So something can react to your checking of the file. That might be extremely rare, but we don't like leaving things to chance. We don't want just random bugs happening every once in a while, because we left a 2 millisecond window open where a bug could occur and we didn't handle that situation. So we don't leave it to chance. We're going to throw an exception. And Java doesn't even let us leave it to chance. It'll say, hey, this code throws an I/O exception. You have to catch that, or I'm not compiling your code. So Java agrees with this. It has to. And situations like this do happen. The Spotify app that I use to start and stop the music, One of the bugs I had earlier in the semester, which I think everything's stable now, but one of the bugs I had was the token expiring. So Spotify, the API, you get a token, an access token, and that token is valid for exactly 1 hour. 1 hour after it's issued, you try to use that token, and it's invalid after an hour. So I have code that checks if my token's valid. If my token's valid, then I'm going to start or stop the music. I'm going to check right before I start or stop it. And if the token's invalid, I'm going to ask for a new token, get the new token, set that as my token, and then use that the new token. So my code is check if my token's valid. If it's not valid, get a new token, and then play or pause the music. If my token's valid, play or pause the music. And my code was doing this. Is my token valid? Yes, your token's valid. Okay, play music because it's the end of lecture. Your token's not valid. In that window between my two method calls, my token was being invalidated, and it was driving me nuts. I'm like, how is this happening? Well, it's because the token's valid for exactly 1 hour. Exactly 1 hour ago, I renewed the token because it was the previous lecture. So my previous lecture, exactly, give or take a few milliseconds, 1 hour prior, I got a new token which expired in between those two method calls. So these things do happen. We don't like leaving things up to chance, but sometimes it's not chance. Sometimes we create the exact situation that will cause the bug just by whatever circumstances exist. And that one drove me nuts. So I had to rewrite the whole code and make it more robust. It tries to play or pause the music, checks if it played or paused whatever I was trying to do, and if not, then checks the token again and goes in a loop and keeps trying. So that's why we have to do this try catch. We cannot guarantee that file will exist. Can't happen. All right, so we try to run the code. If an exception is thrown, we go over to the catch. And there's a few little fixes I need to do to these slides. And for what it's worth, for this semester, for 116, we're going to catch I/O exceptions when reading files. That's the only exception we're going to catch. But you can do more with this just for future reference, for your future programming. You can catch multiple types of exceptions. So if you're running code that might throw 3 different types of exceptions, you have code, you're writing really sloppy, dangerous code, and you're like, I'm not going to fix anything or check anything. I'm just going to catch the exceptions. And this code might throw an I/O exception, it might throw a divide by zero exception, and it might throw an index out of bounds exception. You can have a catch block I/O exception. This is what you should do if you get an I/O exception. Catch index out of bounds exception, have another code block, and then catch divide by zero exception, and have another code block, depending on which type of exception was thrown. Yeah.
So when you're trying to read only lines from a file, wouldn't it be like more practical to make catch statements for every single type of exception you could get?
No. So in general, you should, I guess maybe this is opinionated. I would like to debate the person who would have the opposite opinion, though. But you should check your code and check if you're getting the exception. Like any exception that's born strictly from things in memory within your control, you should have something in your code that just avoids the exception, that never lets the exception occur. Only when we're going to disk, that's when we need to worry about this exception because we can't control this one. There's no way of controlling it. But everything in our control, let's just control it. So going to disk, anything that involves the network too, we might want to catch those ones, but anything else, we're going to write better code is the better answer. I would never want to see a catch divide by zero in anyone's code ever. I'm just doing that for the example, but I would never like to see that ever. Because just check if denominator equals 0, then don't rely on try catch for your control flow. Okay, and if the exception is thrown, this code shuts down. The rest of the, like if there were 100 lines here, and on line 2 an exception is thrown, the rest of the lines do not execute in the try block. We go right to the catch block and shut down the try. Go right to the catch block, execute that code, and go on with our method. Okay, any questions on file I/O? That's reading files in Java. Yeah.
So like there's something debugging even within the line in the trying, you can't debug it.
You can still debug it. It depends what you mean by that. But you have to, like this just might throw an I/O exception no matter what. And you just have to write your try catch block to handle that exception. So you could, like if you ran the debugger and you called this method on a file that doesn't exist, you'll actually see the debugger go into this method, you'll see it throw the exception, and then you'll see your code go over to the catch block. And the debugger will trace through all that.
And if it has like a lot of lines, like you said, like hundreds of lines,
Mm-hmm.
doesn't if the exception is just like in line 34, for example, it will, if you're using a debugger, it tells you line 34 is when the exception is thrown, or does it just kind of say in general?
Yeah, it depends if you step into the Java method that's throwing the exception or not. If you're not stepping into the Java methods, did I say function there? If you don't go into the Java method, you'll be on line 24, and then you'll hit step into, and it'll go right to your catch block. And then you'll be able to deduce that an exception was thrown by that method. But if you go into the Java method, you'll actually get to a line that says throws new I/O exception. I mentioned this in the other lecture, so I'll mention it here, but hopefully this doesn't apply to anyone in the room at least. Never put throws up here. If I see throws I/O exception right here in office hours, I'm going to be mad at you. Don't do it. I'm not showing you it in lecture. I'm hesitant to even mention it at all. If I see that in your code, I'm going to be mad. I'm not showing it to you, so if you have that in your code, I know that you didn't get that from lecture, you didn't get that from me, you didn't get that hopefully from any of the TAs. And most likely you didn't write that code. Like you didn't think through and think, I'm gonna write throws exception here. And I'm gonna know that. You either had IntelliJ write that code because you got an error and you hit the fix it for me button, or something else wrote that code for you. If I see that, hopefully nobody in the room, because you're all paying attention, you're watching lecture, you're going to do it this way. But anybody who has throws there, I'm going to get mad at them. Yeah.
Does that actually work?
It gets rid of the error. It doesn't work. What throws, I'll talk about it briefly, I might as well. If this throws an exception, you should handle it like this. If you don't, what you can do is just say, let whoever called this method handle it. And then it's going to go up to the next method, which is going to crash your program. So it's a way of saying, I know there's an exception, I'm just not doing anything about it. And it'll get rid of the error, because people put it in their testing methods, which is the top level method, and something else will take care of it, which is JUnit library, which is just going to crash and fail your tests. But it gets rid of their error. So they think it's fine, and then they submit to Autolab, and then Autolab gets the error, and everything breaks. And then they come to office hours and say, why doesn't this work? And I say, because you didn't write that code. You wrote something I never showed you, and you're wondering why it doesn't work. So yeah, hopefully that shouldn't apply to anybody who's shown up to lecture, but the empty seats, at least one of them will come to my office hours with that, and I will be upset. All right. Any other questions on that? Right. So that's file I/O. We're reading the lines of a file, and what we end up with is an array list of strings containing all the lines of that file. But what we need is CSV parsing, so let's talk about CSV parsing. And this also, very similar to what you did in Python. I believe they're still splitting on commas in Python. They might be using the CSV library, doing it the right way, but Python has such a nice CSV library, it's so easy to use. They might be doing it that way. Java doesn't, so we're not. But we're going to split on commas. We're going to get a line, it's comma-separated values. We're going to split on the commas and get all those values separated. This isn't the right way to parse CSV, so here's another one of my disclaimers that maybe one day I'll force students to do it the right way. I don't know. The failure rate has to go way down in this course before I start adding all of these things in. But this isn't the right way to parse CSV. Do not parse CSV by splitting on commas in your career. You're going to get in trouble with that. You're going to have some data that gets corrupted and breaks all of your program. So this isn't the right way to parse CSV, but it's serviceable for CSE 116 because all the data is going to be sanitized for you to be able to work like this. The big problem with splitting on commas is what happens when your data itself contains a comma. Now you just split your data in half, and your values aren't going to be at the indices that you expect them to be. Nothing's going to work the right way after that. The proper way to do this is if your data contains a comma, those commas have to be escaped. And the way CSV escapes that is by putting the whole data value in double quotes. So if you see comma and then immediately a double quote, you know that that double quote is an escape character, and then everything until the next double quote is going to be the value, which will almost certainly contain commas. So that would be the way to parse that. Then you'd have to write extra logic instead of split on commas. You have to look for these double quotes. You have to look specifically for comma quote, comma double quote. And then what happens if your data contains commas and double quotes? Now we have to escape the double quotes, and we can't just look for the next double quote character. We have to look for the one that's not escaped, which I believe is / double quote, to escape a double quote in CSV format. So I could have you code all that, but that all detracts from what I want you to be focusing on, and that's learning how to test methods that take a file name as a parameter. So that's what we'll focus on in task 6 and not worry about all this stuff. Maybe someday I'll just find a Java library that's easy to use and just use that one, but that day is not today. I feel like I had one more thing to say about that, but oh well. Sure, it wasn't important. Let's move on. So what we're going to do is just split on commas. There's not going to be any commas in any of the data. If you try to add a song to the ratings app with a comma in it, I just remove the commas. I have a line of code on the server that just removes all the commas. So you're not going to get any commas in your song titles or artists. Or the Spotify ID, I guess. Hopefully I escaped them there too. But the comma is not a valid character for the Spotify ID. So I'll remove that song anyway. But here's an example. Say I have a line, and this normally would be in a loop. You're going to get all the lines of your file in an array list, and then you're going to loop over that array list, and for each line in the file, you're going to split it on commas using this syntax. I'm just using one string as an example, just to get the idea out there. If I have this line A, B, C separated by commas, I want to split this by comma and get an array list, and I expect splits to be an array list of size 3 containing the strings A, B, and C. So 3 single character strings. It does remove the commas. The commas won't be in these splits at all. And line.split, this is exactly what you would expect coming from Python. It's the same syntax, same method name, everything. Line, so any string has a split method, which is a non-static method of the string class. We're going to split on some delimiter, which is another string, and then that chops it up based on that delimiter. So our value here, every time we see that delimiter, we're going to separate that into separate values, A, B, and C in this case. And then one more of these things. Split returns an array. If you want to work with vanilla arrays, just plain arrays, perfectly fine. Knock yourself out. Have a great time doing it. If you don't want to work with plain arrays, the ArrayList constructor will take a list as a parameter, as an argument, as we saw earlier, and you can convert your array into a list using arrays.asList like we do when we give comma-separated values manually to our ArrayList constructor. Arrays.asList and then new ArrayList. The ArrayList constructor, that's going to give you all your values in an array list. If you just want to work with ArrayList like we have all semester, just add this boilerplate and put line.split as the argument. then you don't have to think about a new data structure. Which we talked about arrays briefly earlier in the semester, but mostly in terms of memory, and that arrays can't change size. It's one continuous block of memory. It's random access. We talked about all those things, and then we said we're going to use an array list, which uses an array under the hood, but adds functionality onto it and gives us the illusion that arrays can change size and gives us a lot of extra methods on top of the array. So if you want to work with just an array, which I don't think is too big of a deal, it's just one of them things that's one additional thing you would have to think about. So if you don't want another thing to think about, just jam in the array list constructor and use an array list. And finally, string to number. So we have data that we're reading, and some of that data is numeric, but when we're reading data, when we're reading files, we're reading them all as strings. Our read all lines returns an array list of strings. Our split is going to return strings. We have strings, but some of those strings represent numbers, specifically the song ratings. We have integer values for the song ratings. How are we going to handle those? Well, we can use these methods. Integer.parseInt is going to convert a string into an int, and double.parseDouble is going to convert a string to a double if the string is well-formed. This is something that can throw an exception. You'll get I believe it's a malformed number exception if the value is not properly formatted. So for example, the string FOUR, to us humans, that's the number 4. But to the computer, to the machine, that's a string that is not a well-formed int, and it's going to throw an exception. And if you're not catching that exception, which you really shouldn't, you shouldn't catch this exception, at least for our homework here, then program crashes. For our CSV data, the data that we're going to work with, it's all going to be well-formed. So wherever you expect there to be the rating of a song, you can assume that that is a well-formed int. Yep.
What if you accidentally use double.parseDouble on an integer? Would it just make it into a double, or
Yep. Parse double on an integer is fine. It'll assume 0.0.
What if the string is something like ABC 15? Would it be like
No. Nope, you have to extract that 15. So like we'll have comma-separated values. You'll split on commas, and at the index where you expect a number, you'll pull just that value and then convert it to an int. Yeah, if there's extra stuff, ABC, what's that? In that example, yeah, you'd have to somehow extract the numeric value. So I would probably use a regex for that to remove all non-numeric characters. Maybe it depends on the specific application, though. We don't quite. I knew it. I said the code's been